This whole video is about section 9.7 from your textbook, special functions. Make sure that you've got your notebook out for notes. Okay, let's look at an example because we're going to talk about piecewise functions first. And they come up pretty naturally. So in this example, you've got a meal delivery service that charges customers $10 per meal if you order 6 or fewer meals per month, and $8 per meal if you order more than 6. So we're going to create a function that can be used to calculate the price of m meals. Okay, well, if m is less than or equal to 6, then we want the cost to be 10 times the number of meals. And if m is greater than 6, we want the cost to be 8 times the number of meals. So here's how we write that piecewise. It's just kind of a fancy version of what we wrote over here in sort of words and math together. This is exactly how you'll see it written. And sometimes there can be more than 2 cases. There might be a third case down here you'll see. Okay, let's look at this graph. There are 2 separate things being graphed here. You can see that up until we get to 6 meals, we've got this line, the red line, where y equals 10x. And then if we get greater than 6 meals, we've got the blue line, y equals 8x. Let's just look at that in Desmos for a second because there's something missing from this graph. Okay, you'll notice as I hover over this, 660, there's a point right there. If you order 6 meals, it's going to cost you $60. But when I try to click on this point, you'll see that it says 6 undefined. That's because that, and you can see a little bit under my cursor, is actually an open circle. This is a closed circle. So when we have something that's included, it's a closed circle. Not included, it should be graphed as an open circle. So let's just go back to our slides and kind of add that in. Okay, in a really exaggerated way, I've added a closed circle there on the 6 for the red line and a big open circle for the blue line. For piecewise functions, when you go to evaluate, you've just got to read the if statements to decide which part of the function you're actually going to use. Let's start with if I've got x equals -5. Well, that is x is less than 3, so that means that I need to use this part of my function, my piecewise functions. So I'm going to do f of -5 is equal to 2 times -5 squared. -5 squared is going to give me 25, so altogether that's going to give me 50. Okay, now what about x equals 3? Well, if x equals 3, I have to use this middle piece of the piecewise function. So I get 3 times 3, which equals 9, of course. So we're using different rules. Here I used the 2x squared rule up above, and here I used the 3x rule, depending on what my input was. Okay, let's talk about if I have x equals 20. Then what am I going to do? Well, now I have to use this bottom rule because x is greater than 3. So f of 20 is 20 plus 1, or 21. Okay, let's check out this function here. So it's a piecewise function. F of x is -x if x is less than 0, and it's just equal to x if x is greater than or equal to 0. So let's fill in some of this table here. Okay, if x equals -3, then I'm in this top case. So I've got -3, that gives me +3. The same thing for -2. -2 gives me +2. 0. Now, if x is greater than or equal to 0, I've got just exactly what x is equal to, so y is equal to x. Okay, so you've seen this function before. Whenever you have something negative, you just output the same number but positive, and if it's positive, you just output the number that you have. What is that function? That's the absolute value function, of course. So normally we would write this, f of x equals x, in the absolute value bars. It's just that this is actually a piecewise function. We haven't talked so much about it before, but the graph of the absolute value of x looks like this. because for all the positive values, it's the same as the line y equals x. And for all the negative values, it's y equals negative x. Okay, so that's awesome because now we have another function we know. We've talked about linear, we've talked about quadratic, we've talked about exponential, and now we have absolute value as another of the parent functions that we can kind of put into our bank of functions. Okay, let's do a little practice here. So write this in your notes as we do it together. Let's evaluate for x equals -5, 0, 4, and 7. For this first function, if I'm doing f of -5, well, that tells me that x is less than 4, so I've got to use this top part of the function. There's nowhere to plug in x. It's just that no matter what I plug in, if it's less than 4, I get out 2. So for f of 0, that's also less than 4, so that's all I'm going to get out is 2. But there's going to be something different that happens here when I get to f of 4, because now that's greater than or equal to 4. So now I'm going to use this part of the function, and I'm going to do x minus 4. So in this case, 4 minus 4, which is 0. F of 7, I use the same rule. Okay, great. Let's come over and do the absolute value. So the key here to doing absolute values correctly is just to remember that the absolute values are grouping symbols. So when I do f of -5, I want to evaluate what's inside the absolute value bars first, and then take the absolute value. So this is going to be the absolute value of -5 plus 3 is -2. The absolute value of -2, which is just 2. All right, you try for 0, 4, and 7, and then check your work. So for the positive numbers, it comes out pretty easy, but make sure that you understand that case with the negative number there. Let's talk about domain and range. Way back from the beginning of the year, we talked about domain and range. These are the functions that we just plugged numbers into to evaluate, and now we're going to graph them. So if x is less than 4, f of x is just the line 2, right? Y equals 2. The y value is 2. If x is less than 4. So anything less than 4, all the way up to here, and it's going to be an open circle because 4 is not included. And then if x is greater than or equal to 4, we're going to graph the line x minus 4. So let's just plug in 4 to make sure we know what we're supposed to get. We're supposed to get 0. Okay, so I'm going to make sure that I put on my line a closed circle. Then my slope is 1. Great, and I can put arrows at the end to show that these go on. Now, what's the domain? Well, are there any x values that can't happen? No, every x value is fine. There's no gap left here or anything. So my domain is all real numbers. My range, well, it looks like I can get any y value that's 0 or larger. So I'm going to write the range as y is greater than or equal to 0. Absolute value of x plus 3. So remember when we plugged in 0, we got 3. If I plug in -1, -1 plus 3 is 2. So -1, 2 is a point. If I plug in -2 plus 3, I get -2, 1. If I plug in -3, I get 0. If I plug in -4, I'm going to get 1 again. So you can see that this is going to look just like the absolute value graph, except it's been shifted over. Notice that it's been shifted left. That's a lot like what we saw with our transformations of quadratic functions. So again, here my domain is all real numbers, and my range is actually the same. It's going to be greater than or equal to 0. Okay, in section 9.7, you'll see more examples, and you'll see this cool greatest integer function, which we don't have time for here, but is a cool function to check out if you're interested. Your practice. Now you can look on page 601 of your textbook, or you can just do these problems straight from the slides or the video. Pause the video if you're going to work on these. And then the next slide is to check your answers. So you can either use the slides to do that, or pause right now, do these problems, graphing and doing domain and range. Your answer should look much like that. On these ones, if you, instead of writing it that way, wrote y is greater than or equal to 0, that's completely fine. And here you might have written y is greater than -3. Notice that this one, because we have this open circle right here at the bottom, we don't have a greater than or equal to -3, just a greater than, because the -3 is not included in the y values. Awesome. Great job.